Here we have an equation of aluminium bromide reacting with potassium to form potassium bromide and aluminium. Now it is of course not balanced. So we're going to change that by balancing it. We'll start by looking at the aluminium. At the start you can see we have one aluminium atom, and at the end we have one aluminium atom. Well, there we go, aluminium is balanced. Great. Not the whole equation though, just the aluminium. So now we move on to the next element we come across, bromine. We can see we have 3 bromine atoms. Now the issue is, on the product side, we only have 1 bromine atom. Well, of course, you can't create or destroy matter in a chemical reaction. So if we're going to start with 3 bromine atoms, we need to finish with 3. Every potassium bromide only uses 1. Well, that's okay. Let's just have 3 of those potassium bromides. If we do that, we've now started with 3 bromine atoms, and we're finished with 3 bromine atoms. Cool, that is balanced. What about the K, the potassium? Well, we started with 1 and we finished with 3. No, you can't just magic up some more atoms. If you finish with 3, you must have started with 3. So let's put a 3 in front of that potassium at the start as the reactants, and there we go. We've now started with 3 potassiums and we finished with 3. The aluminium and the bromine atoms were already balanced. So that equation is now balanced, sorted. Let's look at another equation. Here we have lead bromide reacting with hydrogen chloride to give hydrogen bromide and lead chloride. We'll start with the lead. There's 1 at the start and 1 at the end. So the lead is balanced. By at the start, I mean as a reactant, and at the end, I mean as a product. But the lead is nicely balanced. Let's go to the bromine. 2 bromine atoms at the start, and yet only 1 at the end as part of the hydrogen bromide. Well, according to the law of conservation of mass, we can't just delete some matter. It has to be there somewhere. So if we started with 2 bromine atoms, we have to finish with 2 bromine atoms. One way we can do that is just have 2 of the hydrogen bromide molecules. Every molecule of hydrogen bromide uses 1 bromine, so let's just have 2 of those molecules. That will use the 2 bromines. So the bromine is now balanced. Moving on, our next atom we come across, our next element is hydrogen. We start with 1 and we finish with 2. Now it only shows 1 per hydrogen bromide molecule, but of course we've now got 2 of those molecules. So actually we've got 2 of the hydrogens. But we only started with 1. Well, we better start with 2. If we're going to use 2 at the end, we better start with 2 at the beginning. So there we go. Hydrogen is now balanced. Now, we've got 2 of these hydrogen chlorides, which means we have 2 chlorine atoms. What about at the end? Yep, we have 2 chlorine atoms at the end. So, lucky we put that 2 in front of the HCl, because now the chloride, as part of the lead chloride, well, that's all balanced. So this equation is now balanced, and it's time for another. Cobalt bromide reacting with calcium sulfate. Well, let's have a look. At the start, 1 cobalt. At the end, 2 cobalts. Well, straight away, that doesn't work, does it? If we're going to have 2 cobalts at the end, we need to have 2 cobalts at the start. Cobalt has been balanced. Let's move on to the bromine. We have 3 here, but actually we don't, do we? We've got 6, because every cobalt bromide uses 3 bromine atoms, but I've got 2 of the cobalt bromides. So I've actually got 6 bromine atoms at the start. At the end, I've only got 2 as part of the calcium bromide. Well, let's have 3 calcium bromides then, because that will use 6 bromine atoms. Bromine is now balanced. Now putting that 3 in front of the calcium bromide means we need 3 calciums, and at the start we only had 1. So let's change that and start with 3 of them. 3 calcium sulfates means we've used 3 calcium atoms. We've now balanced the calcium. That then says that we've started with 3 sulfates. Every calcium sulfate has 1 sulfate, but I've got 3 of those whole molecules. So I've used 3 sulfates. Let's check the end. Sure enough, I need 3 sulfates. So that works out, and the equation is balanced. Let's look at a few more reaction equations. Here we start with sodium phosphide reacting with calcium fluoride. Well, let's have a look. 3 sodiums at the start, only 1 at the end. That's no good. Let's make there be 3 at the end. The sodium is balanced. The phosphide, we've got 1 at the start, 2 at the end. That doesn't work out. We need to start with 2. Okay, we can work with this. We'll just put a 2 at the front of the sodium phosphide. Now, we actually just balanced our sodium before. We had 3 of them. But by putting this 2 in front of the sodium phosphide, now that's saying, actually, we need 6 sodiums. So we're going to have to go back and rebalance our sodiums so that there are 6 of them. Now, by putting that 6 there, that says that we're actually going to need 6 fluorine atoms. At the start, that calcium fluoride only uses 2 of them, but we need 6. So we better have 3 of those molecules. And now the last one to balance, the calcium. Well, apparently we started with 3 of them now. Hey, check out the ending. We needed 3 of them. So that works out, and the equation is balanced. Let's do 2 more. Here, manganese is reacting with hydrogen iodide. Well, let's see. 1 manganese at the start, 1 manganese at the end. Grand. Manganese is balanced. Let's move on to hydrogen. 1 at the start, 2 at the end. Hold up. Can't create matter. We better start with 2 hydrogens as reactants. There we go. Hydrogen is now balanced. What about the iodine? Well, we've got 2 iodine atoms at the start, and yet we have 3 at the end. Well, that isn't balanced. Now, what's a number that both 2 and 3 go into? Well, if you're anything like me, you're thinking of the number 6. Let's aim for 6 iodine atoms. So if we have 2 of these manganese iodides, that uses 6 iodine atoms. We've already got 2 hydrogen iodides, each one using 1 iodine. We need to get 6 iodines. So let's change that 2 and make it a 6. Now, that has messed up with our hydrogen balancing. Hydrogen was balanced earlier, but now it's not. We started with 6 and we're only using 2 at the end. Well, let's use 3 of those molecules. So now we've got 6 hydrogens. The manganese is also messed up because we started with 1 and we somehow ended up with 2 at the end. So we'd better start with 2. And now the equation is balanced. But you can see we had balanced the manganese and we had balanced the hydrogen. And when we went to balance the iodine, that actually messed up the hydrogen's balancing and it messed up the manganese balancing. Yeah, that happens when you're balancing an equation. Sometimes you have to go back and forth a little bit until everything just works out. But as you can see, it has worked out in the end. Final equation. Let's start with lithium. From the lithium phosphate, we need 3 lithiums. At the end as products, lithium bromide only uses 1. Let's have 3 lithium bromide molecules. So lithium is now balanced. When we did that, that says we're going to need 3 bromines. At the start, there was only 1. So let's make 3 molecules of sodium bromide. Now we've got 3 bromines. Doing that says we're going to need 3 sodium atoms. Well, that's cool. We have 3 sodium atoms. And let's just check the phosphate. We have 1 as a reactant. We have 1 as a product. That equation is balanced. So this is what we need to do with balancing equations. We essentially just go back and forth until everything works out, because you cannot create or destroy matter in a chemical reaction. All you're really doing is rearranging the bits that you have and making something else with them, but using all of the bits. So that's it, balancing equations. Well, that's the video done. If you liked it, brilliant. Hit the like button and leave me a comment too. Now you know what to do. Go hit that subscribe button. We'll see you next time.